Okay, so we're looking at note 6.5, which is linear transformation applications. Example 1 says a trophy company charges $175 for a trophy plus 20 cents per letter for the engraving. The total charge for a trophy with x letters is given by the function f of x equals 0.20x plus 175. So first it says to enter this equation into y1 equals in the calculator. So the way that you'll do that is on your calculator. Turn it on and go to your y equals and clear out anything that's there. And we'll type in the function 0.20x plus 175. And then on step 2, it says enter the window settings below. So to do that, you go to your window key on your calculator. It wants the x minimum to be 0, so I'm just going to push clear and then change the x minimum to 0. It wants the x maximum to be 7, so I'm going to arrow down and clear and push 7. It wants the x scale to be 1. The y minimum, it wants to be 170. The y maximum, 177. And it says to leave the y scale at 1. So we've got it exactly how we need it. The next thing it says is notice the graph of the function on your calculator. So to see the graph, I'm just going to push the graph key up here in the corner. So that's what the graph looks like. And then it says write a new function that would describe the situation if the trophy's costs were lowered to $172. So for the new situation, I'm going to use the same exact equation, except for that instead of 175 for the trophy, I'm going to use 172. So I'm going to use g of x just to kind of make it different. So g of x equals 0.20x plus 172. And then the question below says, how will this change the graph? Well, the only thing that changed was the y-intercept, and it went down 3. So I would say the line will be parallel but shift down 3. Okay, and then the next question says, enter this function into y2 in a calculator and was your prediction accurate? So over here in the y equals, I'm going to leave this first equation in y1. I'm going to arrow down to y2 and type our new equation as 0.20x plus 172 and look at the graph. So I can see that those lines are parallel to each other. And if I look over here, here's my y-axis. So here was 175, 174, 173, 172. So it did just shift down those 3 units. So we were accurate about that. So to answer this question, we would just say yes. And then it says, going back to the original function, f of x equals 0.20x plus 175, write a new function that would describe the situation if the charge per letter were raised to 50 cents. So instead of the charge per letter being 20 cents, we're going to let it be 50 cents. So that would change the slope, which is going to change the steepness or flatness of the graph. So 0.50 is a bigger number than 0.20, which means that the graph will be steeper. And then it says to enter the function in y2 in the calculator and was your prediction accurate? So it would look like, I'll just put h of x equals 0.50x plus 175. So I'll go over my calculator and clear out y2 and put 0.50x plus 175. So there's the original. And there's the new one, so I can see that it did get closer to the y-axis, so it is a steeper line. So yes, our prediction was accurate. All right, and then we have example 2. It says a florist charges $25 for a vase plus $4.50 for each flower. The total charge for the vase and flowers is given by the function f of x equals 450x plus 25. The first question here says, what is the cost of the arrangement shown in the picture? So if I look up here in the picture, I see there's 1, 2, 3, 4, 5 flowers, and it's $4.50 per flower. So in my calculator, what I'm going to do So I'm gonna go to the home screen and I'm gonna push 450 per flower, and we said there's 5 flowers, so I'm gonna do 450 times 5. Plus, I do $25 for the vase, so that'd be 47.5 or $47.50. And then it says, how will the graph change if the vase's cost is raised to $35? So here's 25, that's what it normally was. If we raise it to 35, and that's just changing the y-intercept. So parallel line, so the slope isn't going to change. And then the y-intercept would shift up 10. And then next it says, how will the graph change if the charge per flower is lowered to $3? So here, the charge per flower was $4.50. Here it's $3. So when we change this value, we're changing the slope. So if I'm decreasing it from $4.50 to $3, anytime you decrease the slope, that's going to make the line flatter. So I would say y-intercept would stay the same. But the line would be flatter. And then it says, do you think a translation or a rotation will have more effect on the overall cost and why? It could be either one, so it would just depend on the number. So if it was a large translation where the line shifted a great amount, that could be the right answer. A rotation is where it would get steeper or flatter. So it would just depend. If you're charging $8 per flower instead of $4 per flower, that could get expensive really quickly. So really that's just kind of an opinion question on that one. And that is it.